All right, everybody. I'm going to move on a little bit when we were talking about concentration. Just a little mini topic here, and this is the subject of something called dilution. And I think all of us have experienced a dilution or something that gets watery when we talk about food and drinks. All right, so if we use this as a little bit of an intro, we know that if you had some iced tea and you poured yourself a glass of iced tea or any kind of drink, and if you add water to this, that or ice to this, that when that ice melts, it just gets watery, right? It tastes less sweet than it did before. And if you think about it, the original drink that you had a certain sweetness to it. And when you add the ice to it or the water and it melts, the tea and the sugar, so if this was iced tea, really the tea and sugar hasn't changed. But what changed, or the amount of tea and sugar hasn't changed, but what really has changed is the amount of water that you added, right? So once that ice melts into liquid, it mixes with everything and makes things watery. So the idea of this is something. So what you've done is you've diluted it, or something is diluted. Okay. Now sometimes we want to make and sometimes this is useful. Sometimes we can take very concentrated solutions, okay, and make them less concentrated on purpose by adding water to or watering them down. You can do it that way. And the process of doing this is called dilution. All right, and there's two ways that this helps in real life. It really makes storing and shipping certain beverages easier. So again, beverage companies will do this. They'll send like a very, very highly concentrated, like Coca-Cola does this, right? And the beverage companies, they'll send like a very concentrated sugary syrup solution. Okay, and then when they ship that to restaurants, those restaurants will then take water and add it to it up to the sweetness that they want to sell the drinks. Okay, we can also do this with chemical solutions. We can create very concentrated solutions, store very concentrated solutions, and then make any concentration that we want based on those by adding water to them. It saves a lot of space. All right, so the idea behind this is the fact that really, when you calculate this or really find out how to dilute something from something else, it's done with a little formula. Now, we do know that the molarity is equal to moles over liters. We know that's true, okay? And we know that molarity over 1. So if you want to so basically what's going to happen is if you know the moles before, okay, are not going to change when you just add water, that means the moles before must be the moles equal to after you add water, because the moles aren't going to change, right? What's in there is not going to change. What's going to change is only the water. So because moles is really the volume times the molarity, which gives you moles, that means the molarity times the volume before you dilute it must be equal to the moles or the molarity of the volume after you dilute it. So we can use this as a clever little equation to kind of figure out what we need to do here. All right, so again, stock solution. So sometimes we call it a stock solution. A stock solution is something that you have before you dilute. So we can think of this as becoming a stock solution, okay? And this is after dilution. That's why you have the 2's here. So this is condition number 1, condition number 2. All right, so think about that. So if you have a certain amount of moles here in this solution, so you say this is like the sweet drink, and then you add water to it, you really have the same number of molecules out of that, right? So think of those in certain moles. The 2 beakers, had the same number of molecules in them. All you did was add water, right? So that allows you to use this. So visually, you can see how this works. Okay, so let's bring up something that would happen, really a situation would happen in a lab if you were actually in a lab. And it says how much concentrated now 18 molar sulfuric acid is needed to prepare 250 milliliters of a 6 molar concentrated acid. So what we want to do is we start out with the real sweet stuff. Again, the higher the molarity, the more concentrated the solution is. And let's just say I don't want 18 molar. I want only 6 molar. So by adding water to the 18, that will dilute you down to 6. Okay, if you increase that volume with water. And we only want to make a small amount. We only want to make 250. All right, so if I look at a picture of this, okay, let's just say I had a solution and I have a certain amount of 18 molar. That's my concentrated stock solution, so I can take that out of a storeroom or out of a bottle. Okay, I want to know how much of this, okay, so really how much of this really strong stuff, okay, do I have to take out of that to put into this beaker and then fill it up to water so that I hit the 250 milliliter mark? All right. So that's really the point, what I want to do. So I'm going to put water in here, but I have to take some of the sweet stuff out, put it in here, and then fill it up to 250. How much of this strong stuff do I need? All right. So that's a really good question to answer in this case. All right. So basically, how I'm going to answer that is I'm going to use my dilution formula. I'm going to say molarity times the volume of condition 1 equals the molarity of the condition times the volume of condition 2. Okay. Now, my condition 2 is over here, right? I want to make a 6 molar solution. Okay. And I want it to be 250. Okay. So I can pair up those two numbers for 2. Now, I already have a molar solution of 18 molar. All right. And I simply want to know what volume of that would I need. Okay. Because again, whatever I take out of here is going to stay in there. I'm just adding water. Okay. So now I would divide this by 18 and divide this by 18. Right. If I use my quick algebra, and you're right, it's all just algebra. Okay. And that number would be simply 6 times 250. Okay. And I would divide that by 18. Okay. And I would get 83.3 milliliters. Okay. So that's what I would need. So basically, if I take 83.3 milliliters of this really strong stuff, okay, and I take it out of this beaker, and I take it out of a little use a pipette, a little squeezy pipette or something like that, and I take it out of here, and I place it in the bottom of this flask, and then fill it up with water to 250, I would then have a 6 molar solution. Okay, so I could do this with any volume, with any concentration, by using this little formula. So it really makes it easy, and you can see why I really don't need to store all different types of solutions. I just need to store something of high concentration, and I can just dilute it with water whenever I want. So it makes things a lot easier. All right, so really that's the whole crux of this, or really how to do this. Again, you're using the principle of molarity. So next, all right, so let's just do a couple of quick problems with this. It's actually kind of easy. We'll just motor along, make it real quick. So again, how many milliliters of a 12 molar hydrochloric acid solution is needed to make 125 of a 2? Okay, again, I'm going to make 125 milliliters of a 2 molar solution, okay, 2.0 molar solution. And again, I have a bottle of 12. So again, how much of this do I have to take to put in there? Again, pair up your numbers. So basically, M1V1 equals M2V2. Okay, my volume is 125 milliliters. Okay, my molarity is 2.0 milliliters. And again, I want to know how many milliliters of the other stuff. So again, I'm going to use 12 molar here, and I'm going to multiply that by X. Okay, and if I do my algebra, my X comes out to be 20.8 milliliters. So if I take 20.8 milliliters of the sweet stuff, I take that out and I add it to this beaker and fill it up to 125, that would be the case. All right. This is very similar to using the same type of thing, which is what we're going to do. We just do it in reverse. We solve for something on the other side. I'm going to give the answer to this. So the answer to this would be, again, you're going to use the M1V1 equals M2V2 here. Okay, and again, if you figure this one out, the answer to this problem will be 1.9 molar. You should confirm that this is true. Okay, so I would pause the video at this point, and I would work this out and make sure you get, you working alongside here. Okay, the third example is kind of interesting in this. So this is example number 3. This is kind of an interesting one. Okay, this says to how much water should 120 milliliters of 180 sulfuric acid be added to prepare a something molar solution. So that's kind of interesting. All right, so if we should take, so basically, we're going to take M1, I'll put it over here. We're going to take M1V1 equals M2V2, okay? And basically what we're going to do is we're going to take a beaker, all right? And what we want to do is we want to make a certain amount of solution here. So we're going to make, all right, we want to make a 2.5 molar solution. All right, so we're going to take, we're going to start with 18 molar, okay, and we're going to multiply it by 120, and that's how many moles I have, okay, and we want to know what the final volume is going to be, so we're going to have to solve for that. So we want it to be 2.5 molar, so my final volume of I'm going to be here, I have to work that out, right? So I'm going to work out that final volume, and that final volume is going to be 864 milliliters. Okay, so basically, I want it to be 200. I want it to be 2.5 molar. That's what I want. I'm starting with 18. Okay, the final volume has to be 864 milliliters. Okay, and I only have in the beaker sitting here, I only have 120 milliliters. So how much here do I need to add, right, to get to 864? Because at 864, I will then be 2.5 milliliters. All right. So you guessed it. If you have to find this difference, if I already have 120 and I got to get to 864, I have to get 864 minus 120, which is 744 milliliters. Okay. So this is another way you could do this. We can actually figure out how much water you need to dilute. All right. So again, a little more of a twist to this, but that's an important way to do it. So again, what does this really prove? Just remember that the V's here are final volumes, right? So what's the final volume when you have 18 at 120? What's the final volume will be 864. If that's the final volume and you only have 120 sitting in the beaker, you need to get water in there to dilute that, all right? And that's the key, all right? So I hope this helps. If you need to watch it again, rewind and enjoy.